Hi guys, it's Mrs. Allgood again. We're talking about signaling in bees here. I know it seems like an odd little detour from what we talked about earlier, but there's a pretty unique system that bees use to signal each other about where food is located. So I want you to be familiar with this system. Okay, so when a honeybee finds food, it uses two known tools to understand where it is. So first is a solar compass. So you're going to see this throughout the next couple slides. The bees are usually going to tell one another where the food is in relationship to the position of the sun in the sky. Okay. And then they also have sort of an internal clock where they can kind of keep track of how long it took them to find that food source from where they started. So they use a solar compass, so they do everything based on the position of the sun in the sky, and then they also use their internal clock to help them keep track of how far they have flown. Okay, so I'm going to keep moving. If you need to pause the video, please pause the video and catch up. Okay, now we're back. So to tell other bees where the food has been found, there are two types of dances that it can perform. Okay, the round dance, okay, which is just kind of what it sounds like. They're kind of moving in a circle, and then they might go back and go the other way in a circle. It basically just is performed if food is nearby. It's not as specific as the other one that we're going to talk about, which is called the waggle dance. The round dance doesn't convey much information about where the food is, but it tends to give enough information that the bees can find it. Again, that's because the food is nearby. If the food is farther away, they're going to have to use more specific signaling to tell the other bees where it is, and so that's when they're going to use the waggle dance. Okay, so I've got, I think, a little video that shows you this. So let's see if this will play. Okay, so what I want you to watch is these bees in the middle. Okay, he's doing the round dance. So he's going in that circle, and then he's changing direction, and then he's doing that, and then he's going that way. Okay, that is the round dance. Sorry. Okay. Let's keep moving. All right, then there's the waggle dance. Okay, so the waggle dance is going to be performed when the food is far away, because it's going to help tell the other bees where the food is in relationship to the sun. So there's a couple key bits of information here. All right. This dance it's called the waggle dance because it's kind of like they're wagging their rear end. It's like kind of a zigzag motion. And so the speed of which they return, the speed of the returning loops, lets the other bees know about the quality of the food source. Like in other words, if you were excited, like you went to go see a movie and you came back quickly and told all your friends about it, then it was a pretty good movie. So if the returning loop of this waggle dance is quick, then it tells the other bees that it's a really, really good food source. Okay? The waggle part tells them where to go. So it is a directionality. It is an angle in relationship to where the sun is in the sky. Oh, sorry. All right, let me see if this video will play. I guess we have to watch the ad first, so we'll watch the ad first.
is hungry. Some 30,000 honeybees.
Elijah Tate, please report to the main switchboard. Elijah Tate.
In any store requires 1 million flower visits. Scouts disperse several miles in each direction, searching for untapped fields. This scout makes a promising find. Pollen sacs bulge from her legs, but she can't harvest all of it herself. She needs help. Lots of it. She spreads the news of her find by dancing. This waggle dance is based on a figure 8. The scout moves at an angle, waggles, reverses direction, and waggles some more. Her flower point presentation has to communicate 3 things. First, she moves at an angle. The angle indicates the direction of the flowers in relation to the sun. The hive's honeycombs are built vertically, so straight up means towards the sun. Down means away from the sun, and so on. Second, distance. She waggles her abdomen rapidly. The more she waggles, the further the distance. Third, flower type. The pollen she collected provides a scent cue for the others to smell for. The presentation is a success. Several sisters return with her to forage in the field. They, in turn, will bring back more pollen and spread the word until the hive is finally full.
Okay, so let's keep going. All right, one more way that bees communicate. So when nectar is brought back to the hive, if the workers accept the nectar eagerly, it lets the scouting bees know that the hive needs more. So that kind of makes sense. If you're, one of your parents goes to the grocery store and you're quick to unload it, it means, hey, we probably didn't have much food in the house. We're eager to see the food. If they unload it slowly, it tells the scouting bees that the hive has enough because they're not really as eager to unload the nectar that way. Okay, so just finish filling in your blanks there. Like I said, if I ever go too fast, you can just pause the video and then press play again. Okay, we're going to move on to mimicry. So there are 2 types of mimicry that we see. We see Batesian and Mullerian mimicry. Okay, and I want you to understand the difference between these 2. Oops, sorry about that. So with Batesian mimicry, a palatable or normal tasting, harmless species mimics an unpalatable or harmful one. Okay, so basically you have the Viceroy butterfly that has a very similar coloration pattern to the monarch butterfly, which I don't know that it's poisonous, but it certainly doesn't taste very good. And we see the same thing with the Texas coral snake and the Louisiana milk snake. So notice it says red and yellow kill a fellow. So this is the one that is venomous. And then this one, red and black, venom lack. So if the red and the black are next to each other, then it is non-venomous. Okay, but they have similar coloration patterns so that a predator would stay away from this one, because it might be confusing it for that one. Okay, so just same thing here. A predator may stay away from this one because it mistakes it for that one, which is either not very tasteful or it could be poisonous or venomous in the case of a snake. All right, let's see how Mullerian mimicry is different. All right, Mullerian mimicry, 2 or more harmful or bad tasting species resemble each other. So you've got a yellow jacket and a bee, or a wasp and a bee. They both have that yellow and black striped coloration pattern, and that serves as a warning to the predators that to not eat them. Okay, that we sting, don't mess with us. So think about all your bees and your wasps and your hornets, how they tend to have a similar coloration pattern to each other, and they all can sting you. Okay? It's not that a non-harmful one is disguising itself as a harmful one. It's that they're all harmful. So they all look that way. It's a warning. Okay? All right. Then we have something called aposomatic coloring, which is a bright coloration that serves as a warning to predators. So a lot of times, like when you see a poison dart frog, it may not be this color, but it will have a very bright color to it. That is aposomatic coloring. And so orange seems to be the most common aposomatic color out there. Even though we wouldn't think of it that way because it's not a bright color, the black and white pattern on a skunk is considered to be aposomatic coloring. Okay? So just remember that the black and white coloring on a skunk is considered to be aposomatic, even though it's not considered like a bright color. Okay? All right, and then a little bit of terminology with like internal clocks. If you hear that, you know the term nocturnal. That means those are animals that are active at night. We heard that a lot with our biome presentations. But if you hear that something is diurnal, those are day active animals. So like most of us are diurnal. We are active during the day, whereas nocturnal means you're active at night. And then finally, circadian rhythms. You'll hear this term a lot. We'll talk about it again when we get to plants. Circa means around, and dia is day. So a circadian rhythm, that means around a day. This is an internal biological clock set to around 24 hours. Okay, so what we see with that is experiments that we've run, animals kept in constant darkness and at a constant temperature still demonstrate daily cycles of eating, drinking. So it suggests an internal clock of some sort. So think about on the weekends, or, well, I guess it's a bad example as far as wake up time, but maybe you get hungry around the same time on the weekends that you eat lunch here during the week. Or maybe during the summer it takes you a little while to get adjusted to your new summer schedule and being allowed, being able to sleep in every day. So it suggests some sort of internal clock when you get hungry around the same time of day, when you wake up around the same time of day, or you get sleepy around the same time of day. Okay, that suggests a circadian rhythm. And I think that's it. So we are good. I hope you enjoyed Animal Behavior Part 2. This was bees and the waggle dance, as well as mimicry and coloration and internal clocks. Thanks.